In today's lesson, we're going to take a look at the last shape we have to deal with. That would be spheres, so like a ball, three-dimensional circles, if you will. And here, we're not going to go through the same formula because every formula we've dealt with so far has had a base. We've had to decide how many bases are stacked on top of each other. But with spheres, there is no base. There's no bottom to this shape, so we can't use that same formula. So this is the one and only time where we'll have a slightly different formula, and here it is. Volume equals 4 times pi times r to the power of 3, because as a hint we're going to need to use our exponent button at some point. Okay, and then at the end, we're going to divide this whole thing by 3. Okay, so kind of like the pyramid where you divide by 3, but no base involved this time, so slightly different. Okay, so we'll need our calculator for this one for sure. Make sure you have your calculator. We'll talk about exponent buttons again, the pi button again, all that fun stuff. Okay, start with the basic one. Here's the sphere. Let's find its volume. So my formula, 4 pi r cubed over 3. And be careful to make sure we're using our radius, which in this case we are, center out. 6 to the power of 3 divided by 3. The nice thing about scientific calculators is you can type this all in at once. Just be careful to use the right buttons. Okay, so we're going to do 4 times our pi button times 6. And remember our exponent button is the one that looks like the upper pointing arrow up here above the dividing thing. On your calculator you should have the same button. So make an exponent to the power of 3. You have to go over because I want to divide all of this by 3 afterwards. So make sure you're not just dividing the exponent by 3, the entire expression by 3. If you did it right, you should get 904.78, let's call that. And our units are meters, and we're cubed. That's it. There's the sphere. That's all we have to do. And get you guys to try this next one here. Volume equals 4 pi r cubed over 3. What is r? Well, this time they give us the diameter all the way across the circle. So my radius is my diameter divided by 2, so 21 cubed divided by 3. Again, all into our calculator, make sure you use the exponent button, and you're going to get a really big answer this time. You should get 38,792.39 cubic feet. A really big number. Like 21 cubed is 21 times 21 times 21. It makes sense because it's a really big, giant number. Okay, this is kind of all we can do with spheres. Okay, we find the volume of them. The only different thing we can do is, well, cut it in half. Call that a hemisphere, half a sphere. So how would I do this kind of question? Well, I take my old formula, 4 pi r cubed divided by 3. And like we've done before when we had parts of shapes, well, divide it into parts. In this case, we have half of something, so let's divide it by 2. So what do we got? 4 pi times 18 cubed divided by 3. And then again, we're going to divide by 2 afterwards. So what I would do with my calculator is I'd do the first part. I get 24,429.02. And then I'm going to divide that by 2. And end up with 12,214.51, this is inches this time, cubed. Okay, the exact same thing, but we only want half of it, so we have to divide by 2 at the end. You gotta try the last one here. So volume 4 pi r cubed. I keep writing the formula to remind myself what it is every time. I've got half a sphere, so I'm going to divide by 2. Okay, my radius. Oh, they didn't give me the radius, give me diameter again, all the way across. So I've got divided by 2 to get the radius. Make sure we're always dealing with radius. Uh-oh, I got big numbers again. 24 cubed. That's going to be a giant number. I got divided by 2 at the end. 57,905.84. But get divided by 2 at the end. So we end up with 28,952.92 meters cubed. Okay, there we go. That's spheres. Whole shape, part of the shape. Let's look at some problems we can solve with them. So DrugCo has designed a new pill. What volume of liquid can the pill hold? So if we take a look at the picture, what do we see in the picture? Well, I see sort of like three shapes. I've got this thing on the top, like a hemisphere, and a matching one at the bottom, another hemisphere. If I put those two things together, if I didn't have that part in the middle, what would that form? I think it would form one sphere. So even though it's two separate shapes, combined, it really makes one shape. We'll call that a sphere. And what's the shape in between those two hemispheres that separates them? Well, really, that's a cylinder. And this part in the middle, right here. How do I find the volume of these things? Well, we know sphere is 4 pi r cubed divided by 3. Now, I'm not going to do this divided by 2 thing for the hemisphere because, as I said, if I combine the top, this part, and the bottom, this part, that makes one sphere. So I don't have to divide by 2 and then put it back together again. I can just figure it out. Okay, my radius of this sphere is 8. All right, center out, cubed, divided by 3. Type in my calculator, and I got 2,144.66 millimeters cubed. Okay, but there was another shape. There was a cylinder. A cylinder is a prism. To do prisms, we always start with the base. The base of the cylinder is a circle, pi r squared. But I know the radius. We just talked about that. It was 8. Okay, in our calculator, we get 201.06. That's just one circle. We've got a whole bunch of circles stacked up on top of each other again. How many circles? 15 millimeters worth. So my volume is base times height. And I'm not dividing by 3 this time because there's no point, right? No, it doesn't come to a point. Times it by 15. And I got 30,015.9 millimeters cubed. And what was the question? The question was, how much volume of liquid can the pill hold? Well, the pill is made up of both of these parts put together. So I'm going to have to take my two answers and add them together. And if you do that, you should get 5,160.56. And it's a word problem, so therefore, the pill can hold 5,160.56 millimeters of liquid. Done. Okay, so a sphere and a cylinder put together. That's kind of the ones we can solve with these kinds of shapes. But these spheres can only really go with cylinders nicely because they stick on the end of them, right? They're both circular kinds of shapes. All right, let's try the last one here. Just in time for winter here. Jack and Joe are building a snowman of 3 large snowballs. Each ball is 75% of the volume of the previous ball. If the first snowball has a diameter of 3 feet, how much snow do they need? So what's their situation? We've got a snowball, and then a smaller snowball, and then a smaller snowball. They gave us information about the first one. They told us it has a diameter of 3 feet. So I can find the volume of ball number 1. Let's do that. 4 pi r cubed divided by 3. Or in this case, our radius, they give us a diameter. So my radius will be 3 divided by 2, which is 1.5, divided by 3, should be 14.14 cubic feet. Okay, that's ball number 1. What do we know about ball number 2? Well, it didn't tell us anything about the size of it except that each snowball is 75% of the volume of the previous ball. So it goes back to the very beginning of our course. We talked about percentages. I need to find 75% of the previous ball. Well, if you remember from way back when, percent is always out of 100. times the pieces that I need. We call that unit rates. So you should get 10.61 cubic feet. Here's ball number 2. How do we do ball number 3? Well, again, we know it's 75% of the previous one. So if this previous one was 10.61, we can find 75% of it by turning into a fraction times the portion that we need, which gives us 7.96 cubic feet. Okay, what was the question? It wasn't how big the top ball was, it was how much snow do they need all together? How much snow do we need? Well, the first one was 14.14. And the second ball was 10.61. And the third ball was 7.96. So altogether we end up with 32.71. And it's a word problem, so let's give ourselves a word answer. Jack and Jill will need, what was our number there? 32.71 cubic feet of snow. We're done. Okay, so some applications of how we can use spheres. Okay, they already just use the one formula. There's no tricks to it unless it's half of a sphere. And just remember to divide by 2 at the end if you have that case. And we also did a problem solving there where it looked like hemispheres, 2 halves. So really we could just stick them back together and make one whole sphere. Okay, give this sheet a try. If you're stuck, come see me. Otherwise, that's pretty much the end of this unit. We're done volume. So the next thing we're going to do is review, and then we'll have our test.